All right. I'm Wang here from HDB BRI, and we are looking today at rainwater harvesting. We started that quite a number of years ago, and at Yuhua Estate. I'm not going to go to this. Green plan, green. Yeah. Okay. Now, what we have in HB towns at the moment, we have existing BTO estates, existing green towns, which are already there, and new ones which are constructed on a yearly basis. And we are trying at the moment to get all the new towns, okay, all the new BTO projects to have a rainwater harvesting system, which we call it urban water harvesting system. And for the existing green estates, we will look at it, and if it warrants, we can go ahead with doing it, but it will have to be done on a selective basis because of higher costs since it's infill sites. And a service diversion is an issue which we have to contain. Now, our challenge statement is how to manage and mitigate these extreme rainfalls. We know that the rainfall has been, as far as intensity and duration, it has been moving and trending upwards since mid 2015 to 2016, and becomes more pronounced, especially in Singapore. Lately, you have longer, cooler temperatures like what we are facing now, and you have higher rainfall intensity. At the same time, this is also felt in other parts of the world, but fortunately, we do not suffer such high high occurrences, and we do not suffer such high damages to infrastructure. But nevertheless, planning ahead, we intend to make sure that when the water, when the rainfall comes at heavier and longer duration, we will make sure that we don't have flash floods, and that we make use of the water in smart irrigation and also in using it on a wider scale, such as cleansing and maintenance for the void decks. So in the dry periods, of course, this harvesting system, we will top it up with uh, water from PUB supply, but we want to think of ways in which we can manage to spread out and contain some of it, and not let it off to the downstream uh, to the downstream waterways. Now HDB is looking for creative proposals that can not just have rainfall detention that is holding it for a period of time, but also retention, the capacity to ensure that we do not have uh, flash flood recurrences. Detention to have it such that we can use it for non-portable use. And we want to also ensure that our city, we fortify our city against excessive rainfall. That means we have to manage the coefficient runoff so that water pollution and flooding is mitigated. The other thing is we are trying to steer Singapore towards a more sustainable future together with PUB. And that comes from, again, intensifying rainwater recycling to effectively and also to safely reuse rainfall for other non-potable purpose like toilet flushing and irrigation. So the more common sites that we see, like in rainwater harvesting, is cleansing of the void decks and also the basement car parks using the rainwater that we harvested uh, from the detention tank. We treat it, we send it over to the harvesting tank, treat it, and then over to the storage tanks for usage. And in our water sensitive urban design, and of course, how it looks is that we're going to create very large tanks which are uh, underground, and most of which are underground, and they will be located close to uh, the harvesting tank, adjacent in fact, and also not too far from the void decks, which will contain the treatment rooms, which can then be used to process, treat the water before sending to the other void decks for usage. The other aspect is we are exploring also the eco pond. This is an area which we are exploring, and we are thinking of doing it over at Bukit Batok. That is another form of water detention, and where area allows for, this is what we want to see, whether this alternative is feasible. Important aspects that we require is that all these processes have to be scalable, and in terms of material usage, whether it would continually be basically reinforced concrete for the tanks, and equipment usage or the technology, whether we will use membrane, or even if need be, if there are ceramic form of membrane, the filters, then we may consider using it. Then integration also to make sure that we we can integrate and use less of treatment rooms, less of detention tanks, but have larger unified uh, detention tanks in one area, in one large catchment area, serving a number of dwelling units. The idea is to synergize the construction, and to make sure that the water collected is beneficial and can be sent to the nearby areas which require the usage of non-potable water. Of course, durability is another aspect which is uh, very important, because of life cycle analysis has to be done to ensure that it is cost effective and have high productivity. The cost effectiveness through cost benefit analysis, return on investment or capex, these are tools which have to be uh, carried out and used to show that it makes sense for using the various methods that may be employed. Then another aspect which continually comes about is the ease of maintenance. Ease of maintenance with regards to budget, convenience, knowledge, and the industry must also be up to it and able to provide the services required. And finally, safety and compliance of the safety of using such treatment systems and rainwater harvesting systems within a state, and that the method operating can be easily complied by a number of vendors, so that this will allow for more competitive rates. Okay, and with that, I end my short presentation on the rainwater harvesting system in HDB estates.
Thank you, Mr. Wang. Just a reminder for everyone, anyone who would like to ask a question can please put it in the chat box. Mr. Wang, just to get us started, just wanted to ask, what kinds of solutions has HDB already explored for rainwater recycling?
Okay, we started by first using single blocks and collecting within a certain area on the rooftop. We
Mhm.
brought it down to collecting it on catchment area
Mhm.
on the ground itself, and we decided not to have treatment room for each block, but to have one unified treatment room. But that would be serving the detention and harvesting tanks, which is also unified and located side by side. That will also minimize construction costs. So what we did was to to bring it all together so that they share the common facilities. So the idea is to reduce the number of treatment systems and pumps, and also to have as far as possible gravitational flow. That's
Mm.
why for the uh, later batches BTO, we always go for gravitational flow type of rainwater urban water harvesting system
Mm.
where you have enough of it.
All right. We have note from Pratibha from BOSAC. We offer technological solutions for water purifications and circulation, membrane technology for water purification. Uh, is this project only for rainwater purification or circulation for non-production requirements?
This project is for the entire system. The treatment is just one aspect. It regards the tanks. It regards the tanks, which means the detention tank, to hold back some of the water to so as to mitigate against possible flash floods downstream in certain areas which have been identified by PUB and HDB. That's one area. The next thing is we also look at making sure that the harvesting tank, we don't have an overly large detention tank. Then we have a harvesting tank that is adequately large enough to hold the water and then send it to the uh, storage tank for treatment and be used on the on as as on a as often a basis as required. The treatment system that comes in the storage room is also required. So this is only one aspect. If you're talking about treating, it's only one aspect using membrane technology, which we have. But of course, it improves from year to year, and the systems get better and more economical. That's a interesting and positive aspects of
Mm.
what is happening. Yeah.
All right. So, as you mentioned, membrane technology or purification is one aspect of what we're looking at because the water may be used for a variety of purposes.
Yes.
You mentioned non-potable purposes as well. Um,
Yes.
what are some other ways, Mr. Wang, that technology providers or solution providers can help make this process better, faster, more efficient for you? Is there any other conception that you guys have explored?
We are thinking of downsizing the detention tank so that it can work effect as we possibly want. We don't have to sterilize so much of the land area. The other aspect is also to use filter systems that can last much longer. Uh, Another aspect is to better align and locate uh, through maybe machine learning to get it more accurately positioned in an area or a site within uh, a number of blocks, so that the running of the distribution pipes can be minimized. So this is done all in aspects of cutting down on in optimizing the designer
Mm.
from tanks to distribution to usage of electricity to pumps. Yeah, all these aspects that come up with even better guidelines.
All right. If I may just clarify for those listening, what you're mentioning is that because this system is going to be implemented along with Singapore's existing infrastructure,
Yes.
there has to be some uh, the solution provider can also contribute in planning how this infrastructure will be laid out.
What happens is when we okay, like those that has already been done, we are taking measurements, and we want to take measurements over a period of time, and then we study the behavior and we study the usage and the percentage, and we see how we can encourage greater usage. But if the usage goes to a limit where it's not uh, we are not collecting enough, then we have to rethink how big we want and how much we have to let go in terms of the orifices and the design. So, but of course, when doing all that, the other aspect is also we will learn through a number of designs that's carried out by the vendors. We will have a chance to see how they are positioned within the site. Because if you do it correctly, uh, it will just add cost to the contractor itself. And of course, they have to bear it because it comes partly with the design build project under BTO. So a good design will, a good, fast, quick design will only make sense. Yeah, and of course, when this is done well, it can always be commercialized. Yes.